right, so I'm hoping you actually did these and didn't just say, hey, I know the next video he's going to give us the answers, so I'll just wait and write the answers down. Yeah, you could do that. Are you learning anything? No. So hopefully you're doing this like I'm asking you to. A little bit of academic honesty here, right? Okay, so for the electric mixer, I already told you the switch turns it on, and we were going to call that the input. Now, where is the output? It would be the beaters. Now, what movement does that switch make? You slide it forward to turn it on, you slide it back to turn it off. Therefore, it would be linear, right? The beaters do what? They spin, so they are rotary. There's my 4 points on that one. Okay, flip this baby over. Now we've got the hand drill. The input is the handle you spin. And we just said you spin it, so it is rotary. Where's the output? Output is the chuck. Oop, nice arrow. The output is the chuck spinning. Whoa, focus. Come on, baby. This camera has trouble sometimes. Here we go. The output is the chuck spinning. What type of movement is that? We just said it spins, therefore it's rotary. So now, tell me this, or think about this. What are we changing here? Look, when we spin this crank, it's spinning this real big gear. It's spinning these little tiny ones right in here to spin that shaft to make this chuck spin. So we're changing speed and torque, right? What are we increasing? What did I tell you to remember? Bigger input equals what? Think about your bike. You're riding your bike. If you want to go fast, you put the chain on a big sprocket on the front, right? So big input increases speed. Therefore, this is really increasing speed. This chuck's going to spin really fast. That's what you would need to drill a hole, right? Okay, so we go to the bike. The input would be the pedals, and they are rotary. Spin. The output would be the back tire, and it is rotary. Now, could you say an output on the bike is linear? Yes. We could say, hey, that bike, when it's sitting on the ground and you pedal it, it goes in a straight line. And so that output would be linear. So sometimes it depends on how far out we take things. Okay, the garbage can. The input would be the pedal. Now, most pedals work, if I can get my pen here as you can see it, most pedals you push on and it goes like this, right? They usually don't go straight up and down. Therefore, if it's going like this, it's what movement? Look at our chart. We haven't had this one yet. Look, it would be back and forth in an arc is oscillating. So we write, how do you, I might need to look back. You might need to look back. How do you spell oscillating? OCS. Oscillating. Right? So then our output is the lid, and that is also oscillating, right? Because it rotates around that hinge. There's a hinge on it. Come on, camera. I want, there it goes. Okay, sewing machine, last one. Input is the foot pedal. Though you just talked about, pedals are usually oscillating. Now, here's one for you though, and kids have said, Mr. Wakefield, my mom's foot pedal on the sewing machine is two pieces, and that piece goes, that top part goes straight up and down. That's true. They make some of those new plastic pedals that way. So then in that case, it would be linear. So either one could be okay. Now, where's our output on the sewing machine? It is obviously the needle, right? And the needle does what? It goes up and down, which is called what? Reciprocating. So this is reciprocating. Think I spelled that right? Right? So now we've got all 4 times 6, 24 points on this. Go over your packet, make sure you have everything written in where you're supposed to have things written in and everything answered, and you should get 42 out of 42. Take a picture of each page that you needed to write things on and attach it to Google Classroom. Thank you, and I promise this is it for observing mechanisms.